Imagine placing a load heavier than a family car onto what looks like nothing more than a piece of plastic. Sounds impossible, doesn't it? Yet every single day, plastic pallets quietly carry everything from life-saving medicines to luxury cars and towering stacks of food across the globe. But here's what nobody tells you. Inside every pallet hides an incredible engineering story filled with fire, pressure, precision, and science. Most people never think about plastic pallets because they disappear beneath the products we buy every day. Yet more than 500 million of them move through factories, ports, supermarkets, and distribution centers every year. Think about this. The entire global supply chain would slow to a crawl without these silent workhorses. And this is where our journey begins, deep inside the factories where ordinary plastic transforms into extraordinary strength. You might expect plastic pallets to come from cheap materials, but the reality surprises even experienced engineers. These pallets survive freezing winters, scorching deserts, chemical spills, and impacts that would crack ordinary plastic in seconds. Every curve, every rib, and every hollow chamber serves a purpose. By the end of this journey, you'll never look at a plastic pallet the same way again. Everything begins thousands of kilometers away from the factory floor. The main ingredient comes from crude oil and natural gas extracted from places like Saudi Arabia, the United States, Canada, Norway, and the United Arab Emirates. Deep beneath the Earth's surface, these fossil fuels formed over millions of years under crushing heat and pressure. What happens next surprised even experienced engineers. At enormous petrochemical complexes, crude oil separates into different fractions through fractional distillation. One valuable fraction becomes ethylene and propylene gases, the building blocks of polyethylene and polypropylene. Inside towering reactors, temperatures climb beyond 850 degrees Celsius, or more than 1,560 degrees Fahrenheit, while carefully controlled chemical reactions rearrange tiny molecules into something completely new. The air vibrates with roaring burners, glowing pipes, and shimmering heat. The molten polymer cools into tiny plastic pellets no larger than grains of corn. Every pellet weighs only a fraction of a gram, but millions of them eventually become one industrial pallet capable of supporting more than 1,500 kilograms. Imagine watching endless rivers of glossy pellets pouring through stainless steel pipes like flowing pearls. Their faint wax-like smell fills the packaging hall. Many manufacturers now blend recycled plastic with virgin resin to reduce environmental impact. Used bottles, industrial containers, damaged pallets, and automotive plastics arrive from recycling centers across Europe, North America, China, Japan, and South Korea. Powerful shredders chew the material into flakes before advanced washing systems remove labels, dirt, oils, and metal fragments. The transformation already feels like magic. The clean flakes enter extrusion machines where rotating screws spin between 80 and 150 revolutions per minute. Friction and electric heaters raise temperatures to around 200 to 240 degrees Celsius, melting the plastic into a thick, glowing stream. Fine mesh filters capture contaminants smaller than 0.5 millimeter before the material reaches underwater pelletizers. The result looks unbelievably clean considering where it started. Before the pellets ever reach the molding machines, engineers carefully mix in special additives. Carbon black protects against ultraviolet sunlight. Antioxidants slow down aging. Impact modifiers help the pallet survive freezing temperatures, while color pigments create the familiar black, blue, gray, or red appearance seen around the world. Every ingredient measures down to fractions of a percent, because even tiny mistakes could weaken the finished product. Each finished batch undergoes laboratory testing before anyone approves it for production. Scientists measure melt flow index, moisture content below 0.05%, density, tensile strength, and contamination levels using sophisticated instruments. One failed sample can stop thousands of kilograms of material from entering the factory. Quality begins long before the first pallet takes shape. Now imagine thousands of kilograms of perfectly engineered plastic pellets arriving at one of the world's largest pallet factories every single hour. They disappear into towering storage silos, waiting for the moment they will face incredible heat, crushing pressure, and machines powerful enough to reshape solid plastic in less than 2 minutes. And what happens inside those machines changes everything. The moment has finally arrived. Thousands of tiny plastic pellets rush through vacuum pipes at speeds approaching 25 meters per second, disappearing into giant hoppers perched above injection molding machines the size of small houses. Standing beside one of these machines, you feel the floor vibrate beneath your feet as hydraulic pumps come alive. But here's what nobody tells you. The real transformation happens where you can't even see it. Inside the heated barrel, a massive steel screw, often more than 3 meters long, rotates at 80 to 150 revolutions per minute while pushing the pellets forward. Electric heater bands raise the temperature gradually from about 180 degrees Celsius to nearly 240 degrees Celsius, or 356 to 464 degrees Fahrenheit. Friction between the screw and the plastic adds even more heat until every pellet melts into a thick, glowing liquid. The smell resembles warm candle wax mixed with hot machinery. Now the pressure begins to build. The rotating screw stops spinning and suddenly drives forward like a giant hydraulic piston. Molten plastic surges into the mold at pressures between 1,000 and 2,000 bar. That's more than 14,500 to 29,000 psi. Imagine liquid plastic racing through narrow channels faster than you can blink, filling every corner before it has any chance to cool. The mold itself weighs several tons and closes with an incredible clamping force that can exceed 3,000 tons. Without that crushing force, the molten plastic would burst through the mold like lava escaping a volcano. Every surface inside the mold has been machined to microscopic precision, creating ribs, forklift openings, anti-slip textures, and reinforcing channels in a single shot. This level of accuracy leaves almost no room for error. What happens next surprised even experienced engineers. Even though the plastic entered the mold at more than 220 degrees Celsius, chilled water races through hidden cooling channels at around 15 to 25 degrees Celsius. Heat escapes rapidly until the molten plastic hardens into an incredibly strong structure. Steam rises as thousands of liters of cooling water quietly do their job behind solid steel. Cooling usually takes between 60 and 120 seconds, depending on the pallet size and thickness. During that short time, sensors constantly measure temperature, pressure, and shrinkage to prevent warping. Think about this. Even a difference of 1 or 2 degrees can affect the final dimensions. Precision matters because warehouses around the world depend on every pallet fitting perfectly. With a deep mechanical thud, the mold finally opens. Hydraulic ejector pins push the finished pallet free, and a robotic arm quickly lifts it onto a cooling conveyor before the next production cycle begins. The entire sequence often finishes in less than 3 minutes. The speed feels almost unbelievable considering the pallet can carry well over a metric ton. Some heavy-duty pallets receive steel reinforcement bars hidden inside the plastic. Automated systems position galvanized steel inserts before the next injection cycle begins, allowing molten polymer to lock them permanently into place. This clever design dramatically increases stiffness without adding excessive weight. Most people never realize there's metal hidden inside certain plastic pallets. After molding, rotary trimming tools remove tiny flashes of excess plastic from edges. High-speed cutting heads spin at several thousand RPM, while vision cameras inspect every corner for imperfections. You hear sharp mechanical whirs, feel warm air from the machinery, and watch tiny plastic ribbons fall into recycling bins where they'll begin another life. Almost nothing goes to waste. The finished pallets continue along automated conveyors through cooling stations before robotic stackers arrange them into perfectly aligned towers. Laser-guided forklifts transport entire stacks to massive warehouses, where thousands wait for customers across the world. Every movement follows carefully programmed logistics that waste almost no time. But the biggest challenge still lies ahead. You might think the journey ends here, but this is where it gets truly extraordinary. Before a single pallet leaves the factory, it must survive brutal tests designed to push it far beyond anything you'll ever see in a warehouse. Some pallets fail. Others become engineering legends. And that's exactly where we're heading next. Welcome to the part of the factory that few people ever get to see. Every pallet now enters a world where cameras never blink. Lasers measure distances thinner than human hair, and artificial intelligence hunts for defects in milliseconds. Think about this. Even a pallet that looks perfect to your eyes can still fail here. And this is where engineering meets absolute precision. Welcome to the part of the factory that few people ever get to see. Every pallet now enters a world where cameras never blink. Lasers measure distances thinner than human hair, and artificial intelligence hunts for defects in milliseconds. Think about this. Even a pallet that looks perfect to your eyes can still fail here. And this is where engineering meets absolute precision. Next comes laser measurement. Brilliant red laser beams sweep across the pallet, while precision sensors build a complete three-dimensional map in seconds. Every opening, support leg, and load-bearing rib must stay within a tolerance of about plus or minus 1 millimeter. Imagine measuring an object nearly 1.5 meters wide with accuracy finer than the thickness of a credit card. But dimensions alone don't tell the whole story. Hydraulic tested machines slowly apply crushing loads that can exceed 5,000 kilograms, simulating years of warehouse abuse in only a few minutes. Steel plates press downward, while sensors monitor every fraction of a millimeter bending. The deep groan of steel and the hum of hydraulic pumps fill the testing hall. The punishment doesn't stop there. Engineers repeatedly drop loaded pallets from carefully controlled heights to recreate the impacts of careless forklift drivers and rough transportation. The crash echoes through the building as thousands of kilograms strike the concrete floor. What happens next surprised even experienced engineers. Many premium pallets survive dozens of these brutal impacts without structural failure. Some samples spend weeks inside environmental chambers where temperatures swing from minus 40 degrees Celsius to more than 60 degrees Celsius, or minus 40 to 140 degrees Fahrenheit. Others endure intense ultraviolet light that simulates years of outdoor sunlight. Moisture, heat, freezing cold, and constant expansion all try to break the material apart. Only the strongest formulations earn approval. Every production batch also undergoes chemical and material analysis. Laboratory technicians test density, melt flow index, impact resistance, tensile strength, and color consistency using advanced instruments. Many factories maintain rejection rates below 1% because catching problems early saves enormous amounts of material, energy, and time. Quality isn't inspected into the product. It gets built into every single step. Automation handles most of the work, but one critical inspection still depends on human experience. Skilled technicians run their hands across the pallet surface, listening for tiny sounds and feeling for imperfections that even advanced sensors sometimes ignore. Years of experience allow them to recognize problems almost instantly. In this moment, human skill still beats the machine. Once every inspection passes, automated printers apply permanent identification marks, QR codes, production dates, recycling symbols, and traceability numbers. Every pallet now carries its own digital identity, allowing manufacturers to trace it back to the exact machine, material batch, and production shift. It's like giving every pallet its own passport before it begins traveling the world. Finally, towering robotic arms stack dozens of finished pallets with incredible precision before autonomous forklifts carry them toward shipping docks. In only a few hours, these pallets will begin supporting food, electronics, medicine, automobiles, and countless other products across the planet. But here's the biggest surprise of all. The numbers behind this industry are almost impossible to believe. In the next chapter, we'll uncover the astonishing scale of plastic pallet manufacturing around the world. Now step back and imagine this from above. Every day, millions of plastic pallets move through factories, ports, airports, supermarkets, hospitals, and distribution centers across the globe. Industry analysts estimate that the global plastic pallet market is worth well over $8 billion US, and demand continues to grow as companies replace traditional wooden pallets with stronger, cleaner, and recyclable alternatives. What seems like a simple platform has become one of the invisible foundations of modern trade. Think about this. The world produces tens of millions of new plastic pallets every year, and many remain in service for more than 10 years. Together, they transport billions of tons of products, from fresh fruit and vaccines to automobile engines and heavy machinery. Without them, global commerce would slow dramatically. Most people never realize that nearly every item they buy is rested on one at some point in its journey. Today, China leads global production with roughly 35% of manufacturing capacity. The United States follows with about 18%, while Germany, Japan, and India continue expanding their advanced manufacturing industries. Thousands of factories and suppliers work together across these nations, employing hundreds of thousands of engineers, machine operators, technicians, logistics specialists, and recycling experts. It is a truly global engineering network. The story began more than 50 years ago when manufacturers searched for a cleaner, longer-lasting alternative to wooden pallets. Early plastic designs cost more and carried lighter loads, but new polymers and computer-designed structures completely changed industry. Today's high-performance pallets resist moisture, insects, mold, chemicals, and splinters while lasting through thousands of loading cycles. Decades of innovation transformed a simple idea into a global standard. But here's what nobody tells you. The future is arriving faster than anyone expected. Engineers now build smart pallets with embedded RFID chips, GPS tracking, Bluetooth sensors, and Internet of Things technology that reports location, temperature, humidity, and even impact damage in real time. Some companies already use artificial intelligence to predict exactly when a pallet should be repaired or recycled. The pallet itself is becoming an intelligent machine. Did you know that a single premium plastic pallet can survive hundreds or even thousands of trips, while many wooden pallets need replacement after only a fraction of that use? Did you know some heavy-duty models safely carry loads exceeding 5,000 kilograms under static conditions? And did you know that damaged plastic pallets rarely become waste because manufacturers grind, melt, and transform them into brand new pallets again? That's engineering design for a circular economy. Researchers believe the next decade will bring lighter composite materials, stronger recycled polymers, faster molding machines, and factories powered increasingly by renewable energy. Advanced robots will handle more production, while artificial intelligence continuously improves quality and reduces waste. Imagine factories where almost every gram of plastic gets reused, and every pallet reports its own condition automatically. The hidden world of manufacturing keeps evolving, even when most of us never notice. From ancient fossil fuels buried deep beneath the earth to precision robots working with unbelievable accuracy, you've witnessed a complete journey of a plastic pallet. Every pellet, every degree of heat, every ton of pressure, and every quality test contributes to a product that quietly keeps the world's supply chains moving every single day. The next time you see one beneath a shipment, you'll know you're looking at decades of science, engineering, and human innovation brought together in one remarkable design. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.